Hi guys, in this video I'm going to tear down this display from a Fujitsu Siemens laptop, and my plan is to use the top layers from this LCD on another LCD. So yeah, I don't know if I'm going to able to remove them so they can still be used on something else, but I'm sure going to try. As you can see, this is completely broken. I've replaced it on the laptop with a good one, and this is spare parts now, and of course it will be turned down to the maximum level. So let's start doing this. The bezel is off. Next I will take out the inverter board and the display itself. I'm not going to take out the hinges as they don't really matter to me. This is what really matters. And from what I see, how it reacts here, I think I have a chance on removing the glass from these plastic layers. So that would be really good. But I can know for sure until I actually try it. The inverter board is there. I took out the display. It had 4 screws on each side, these tiny ones, that went into holes on the panel itself. And next, yeah, I'm going to take out this cable as I don't need it anymore. Hopefully I can do this with only one hand. The cable is good, so I will keep it for maybe another laptop, a similar one. It's glued really well here. Okay, that's out. And next, let me just think about it and see how I can tear this apart even more. Okay, also took out the metal bezel that was underneath. It just had metal clips all around, and yeah, as you can see, our display is coming apart at this point. Now, just before that, I would like to try and take out this metal part here. I'm thinking that underneath it we should have the light for the LCD, the CFL tube. Actually, I think it's a CFL. Now, for me this is a little bit easier because I don't really care if I break anything around here. So yeah, but for you, if you are going to replace the CFL or something like that, be a little bit more careful. This had some plastic clips, maybe I broke a few of them, doesn't really matter. You can replace CCFLs on this type of display. So let me see. We still have some metal here, I think. Do we? Yes, we do. Can we take it out? No, we cannot. Okay, maybe from the other side. But before that, I'm going to remove this board because it's of no use. This is the driver for the LCD, but because it is soldered in place, I have no chance of using this on any other thing, so it is useless at this point, and it kind of tears out quite nicely. Let me try, maybe you can actually see something. I don't really think, but come on, get out. And this is out and useless. As you can see, it's really thin board. Most likely you cannot do absolutely anything with it anymore. Some drivers for each of these flexes on them, if you can see. Maybe better here. Okay, let me turn this around and see what we get on the other side. Hopefully I will not cut myself, because this is glass after all. And we are apart. This is the cracked glass, and yeah, it looks really interesting. I will set it aside for a moment, and let me try and go further here. Maybe I can get to this light source here. I think we have some reflector or diffuser at this level. Yeah, most likely this is a diffuser, and I'm going to rip it out. Pretty nice. And this thing creates interesting shapes, a few layers, and another diffuser here. A lot of stuff goes into the making of a simple display. It seems it's not quite simple as it first seems. If I could actually remove this from the plastic frame, that would be great. In the end, I think I'm going to remove the frame from it. Another layer here. Yes, another layer. Maybe you can see this does not have the same thickness all the way. It's thicker at the bottom and thinner as we go up. All these things have to do with the light being uniformly distributed throughout the display, so you see things good. And this also has some small dots on it, also to distribute light correctly. This is just a white background, so all the light is forced out. And I think we have reached the CCFL tube, which is here in the lower part, but it is going to be a pain in the ass to get out. So I'll stop the video for a moment, because I would like not to break it, but who knows. And the tube is out. I'm not going to remove it from this metal reflector, because it will be very fragile. It's extremely thin. I don't even know if you can see it in there. But yeah, this can be used on other displays if needed, although it is quite complicated and the risk of breaking it is really high. Or you could transform this whole display. After you took out this, you close it back together, you modify a little bit the source, the voltage source for this, and you could transform it into something like a light panel, and it will give quite a uniform white light. If you are into that sort of thing, I already have up, you can see in one of my videos, a LED panel for my workspace, so CCFL panel not as good and not needed. So I'm going to set this aside again, and we are back at the glass. And this will be quite tricky, but maybe you can see, or you will not be able to see because the camera will focus onto what it wants, and this being reflective will focus on the reflection. The glass is starting to come off, so I will try to peel it off camera and show you the result in a moment. This is more tricky than it seems. As you can see, there are several layers here, and I'm going to peel them off one by one. There is one, I think it's polarizing, then some glass, then some other glass, and just then the polarizing and the matte filter that I actually need. So yeah, this will not be quite easy, but I'm going to try it anyway. Until now I managed to separate the two sheets of glass that were attached to each other, and each of them have some plastic foils. This is one that I actually do not need, so I will experiment on it, and this is the one that I need. So hopefully I'm going to get this off in only one piece. I've tried, I searched online to see how to get this off the glass. Some say to leave it for a few hours in water. I've done that. I've even previously done that on another display. It doesn't really work. And from my experiments, it seems that only this stuff can actually dissolve the glue and leave the foil alone and doesn't really damage it. So I'm thinking I will crack this in a lot of places and put on the back this type of alcohol, and hopefully it will go through the cracks and slowly dissolve the glue so I can remove the glass. But this will create glass shards everywhere, so it will not be pretty at all. But yeah, hopefully I can do it. Okay guys, I left a part of the display for more than 24 hours in alcohol, 99.9% alcohol, and the glue started to release. Let me just show you, but really fast because the vapors are extremely strong. You can see I managed to pry a little bit of it off, and it's starting to give away. I've cracked it all around so the alcohol can get inside between the glass and the glue and the foil and dissolves the glue. And with this I'm really slowly gonna pry off the glass off the foil without scratching the foil. And then I'm going to clean the foil, but I will not do this on video because the vapors are really strong and I need to go in another place to clean it. Okay guys, this is what I managed to do. Removed part of the glass, but it's going really slow, although the glue is dissolved almost fully. But as you can see, when I start to clean the glue, scratches remain on the foil, so it will not be usable. All this would be for nothing, so sadly I'm going to give up. And at this point this concludes the teardown of a display. I got a CCFL tube, an inverter, some plastic, a reflector, and that's kind of about it. So yeah, what can I say? Thanks for watching. Sorry it didn't work out, And yeah, check out my other videos, subscribe, and see you in the next one. Bye. I have another laptop screen to take apart, so I decided to put it in this video. It might be interesting to see differences in technologies from that display to this really thin display. Now, as a disclaimer, I filmed the first part way back, I think over a year and a half ago, so I don't even know exactly what I told you and what not, and what I actually knew at that point. So I'm going to tell you what I know now. First of all the electronics in this display were covered with this EMI tape. This is a shield for electromagnetic interference, so you don't want this thing interfering with other devices and creating issues, or other devices with this thing. It kind of seals everything in place, including the chips on this glass. So let's throw that away. Don't need it, can't use it for many things. What do we have here next? I'm guessing that this is the connection for our backlight. This thing has an LED backlight, which is kind of interesting. We will see if we can take it out and maybe reuse it in other projects, although it might not be that easy to find a pinout on this thing. They usually have a few strands, is it correct? In case one of them, and the strands are somehow in parallel, each of the LEDs. So if one of the LEDs break, not a full strand will go away, but one LED from here, one LED from the second one LED from the third one, something like that. So in case a single LED breaks, you don't lose light from a big portion of your display. It will just be a bit dimmed down and maybe a bit uneven in the lower part. So yeah, that's quite clever. Now let's get out this tiny screw right here. And it is tiny. Put it aside. What the problem was in this display, one of the flex foils was actually not making contact anymore. So I tried to find a position where it made contact and then use hot glue to keep it in place. It worked for a while, but then started creating problems once again. So yeah, let's try and continue to undo this. I will do it in high speed until I get to something interesting. And we're on this side we have the display itself, or the panel actually. It is reasonably thin, and just as a curiosity, this thing filters a lot of the light coming from the backlight of the display. So yeah, that is one reason why displays still consume a lot of power, because they need to overcome this thing. And on top of it, of the glass, we have the polarizer. So let me see if I can actually get this away. Let's break the flex foils. The data enters the display itself through the flex foils. Yeah, here where I put a ton of glue, it's a bit harder to break, but we might be able to do it somehow, I think. break, please. And it's broken. So all of these flex foils have a ton of tiny contacts on them. That is what brings the data from your laptop to this screen, and the screen itself has a few chips on the glass that drive the vertical and horizontal lines. And when where they meet, they can give a command. So will this fall out now? It should actually fall out. Some double-sided tape still keeping it in place. Let's see if we can peel that from one end to the other. And it seems we actually can. I don't think there are any components on this PCB that are worth salvaging for me. Maybe this connector, but nah. Slim chance of that. And this thing is from AUO. We work with them also at work. You might expect to be a ton of display manufacturers out there, but they are not. They really are not. This might actually shatter in my hands, and it did. And maybe I can show you the effect. The liquid crystal is actually liquid. You can see it in there moving when the glass is cracked. So we still cannot get this out of the way. That hot glue did a thing on it. That's quite interesting. Okay, so absolutely no use for something like that. What do we have here? We have the foils inside the display, the foil stack. If I could get my hands underneath it. And these are glued in place, I think in 4 places. That is to prevent them from rubbing one onto the other and creating dark spots or stuff like that, or debris inside that would affect the quality of the image itself. Okay, quite hard to get this out. And an interesting way of keeping it in place with these tiny holes right here in the corner, and we have a pin right there. Okay, so let's see. I do not know these foils quite well. I'm thinking this is the diffuser, and one of them is the brightness enhancement film, so it's a BEF, and the other is a DBEF, which I'm not even sure what it stands for. Their main purpose is to use as much of the light given by the backlight in here and to transform it into polarized light that can be used by this thing. So yeah. Or actually one of them might be a polarizer. Nah, doesn't seem like it. So let's continue. Let's try and get these edges out. These displays are quite compact, as we can see here. So a bit more tricky to open up compared to older, bigger displays. Again, double-sided tape keeping things in place, nice. If you are thinking about reusing these things, well, maybe the diffuser for something, you can see how it looks. One side is shiny, the other is matte, but yeah, not really, or at least not for me. This foil, some trippy things going on here, and it actually has, maybe you can hear it, it has lines on it on one side, and this is smooth. Again, maybe just for some interesting effects, but that's about it, nothing else. And this thing, yeah, interesting effects, but less of them, but this is maybe a bit more reflective, so who knows. But we can see here where we heated up the display a bit too much and we warped this thing, and that is one reason why we had a bit of color issues in that area. Let's see if we can get this thing out. We still can't. Let's bring a knife to this fight. For such a slim display, this is really well built and put together. Again, double-sided tape holding everything. When you get to this level, you kind of need the double-sided tape. You don't really have many other chances of doing this. So what I'm trying to get out at this point is this, which is the light conductor. This thing takes the light from the LEDs that are below. You can have LEDs on the back of it, in some cases a matrix of LEDs. You can have them on the sides, but this one has them right here in the bottom. It takes the light in the bottom and transfers it into the whole display, trying to make it as uniform as possible. I'm going to show you something interesting about this. You see the clear edges, and then something a bit more matte. Well, those are microstructures. As you can see, they are way less pronounced here, and as we go up they are more pronounced, because their purpose is to take the light that is entering like this and to shine it at us. These are basically, if you look at them under a microscope, tiny lenses, a ton of them, and a ton of simulation goes into where you position those lenses. So that's that. And weirdly enough, this display is so compact that actually the reflector foil from the back of it is also the back of the display, which, yeah, seems fair. Again, yeah, white piece of plastic, might have a use for it, might not. Same for this thing, it's just a thin piece of plastic. Quite flexible, so I might actually keep this one. Maybe both of these, I'm not sure. This, useless. Let me just try and show you if I can actually peel away the polarizer from on top of this. Sometimes it peels away nicely, sometimes it doesn't. Yeah, so this is a polarizer. Without it you wouldn't see anything on your screen, but you can remove it by yourself. Quite hard to do it, and make a privacy display on your own. And I will link 2 videos in the description where I actually made a laptop with a privacy display by removing this and putting polarizer lenses on some 3D cinema glasses to see it only with those glasses. quite a neat thing. But I'm still thinking about the previous foils that I already thrown away. One, maybe we don't have BEF and DBEF. We might have just BEF and the polarizer. Yeah, because we don't have a polarizer on the other side of this thing. So, or actually we do. No, this seems to be directly glass. Which is a bit weird. Is it directly glass? Or is it a polarizer like I'm thinking? Yeah, a polarizer. So no, I was right. Those foils are BEF and DBEF. And we have another polarizer on the first side of this thing and one on this side. Yep. Makes sense. Okay, and now let's try and get out the backlight from in here. And this is not going to be easy. This is crimped in place quite tightly in here. Okay, I need to unbend this whole edge to get to that. That's going to take a bit of time. But you can already see the LEDs down there. That's nice. So I need to unbend this without damaging the LEDs, because if I damage them, well, that becomes useless, does it? Doesn't it? Sorry. And believe me, this is harder to do than it looks. So, high speed video. Started to peel off the LED strip, but it's not reusable in its current form because I scratched or actually broken a few of the LEDs. This thing was really well put together, and this is something that I've noticed with modern electronics. The more compact they are, the harder it is to reuse anything out of them. So yeah. Please get out. Why are you not getting out? The stiffener, this thing right, come on, this thing right over there, the stiffener got caught. So yeah, as you can see, we have LEDs that are quite a bit bent. They might still work, although they are cracked, so probably not. But yeah, I don't know if I have any use for any of these LEDs, but you know me, I'm not going to throw them away. I can roll this thing up on itself and keep it somewhere in case I ever need a really tiny LED like this. And they are quite bright and quite powerful, although they are tiny. And I think quite expensive. So yeah, that's about it. The more these things get smaller, the less we can use out of them. Sad, but it's a fact. So I think this has been it for this video, this time for good. Because I opened up two displays with two different technologies, and if I open up another display, it will probably either be LED like this or CCFL as the first one, so it's kind of pointless. They all have the same construction inside. Yeah, I don't know. That's about it, guys. So thank you very much for watching. Hopefully you've enjoyed this video, in which case maybe give it a like. Check out my channel and my other videos, and as always, see you in the next one. Bye! Just noticed something really nice about this. As you can see, they have test pads in here for each of the LEDs. So you see one of them. That's it has I don't know, a line right there. Means that it's actually interrupted. So this is the first strand, and yeah, weirdly enough, this is not like I thought. This thing just has one strand here, one here, and one here, and if one of these LEDs goes off, this whole thing will be gone. So the technology we use at work is actually better than this one. So yeah, the test pads are just so they can test and make sure every single one of these LEDs is actually working when it leaves the factory. But yeah, anyway, that's about it. Bye.